This is a recorded reading from the Energy and Forces in Motion unit called Describing Motion. You can describe motion with words such as fast and slow, but how fast is fast? How slow is slow? Fast to one person may seem slow to another. To deal with these differences, you can describe motion more precisely by measuring its speed. Speed is the measure of the rate at which an object changes its position. So in this paragraph, it's actually giving you one way to describe to describe motion is by measuring its speed. Let's pop over to the yellow box here and see what they have to say. Speed and velocity are terms that are often used interchangeably in everyday life, but are not the same in science. Speed indicates the rate of change in an object's position only, whereas velocity indicates both the rate of an object's motion and its direction. So in that paragraph, they're actually telling you a second way that you can describe motion, and that's through the velocity, describing an object's velocity. And the difference between speed and velocity is that they both measure how fast or slow something's going, but velocity measures its change in direction as well. To determine an object's speed, you need two measurements: the distance the object has traveled and the time the object took to travel that distance. You can measure the rate at which the object changes position, its average speed, with this equation. Average speed equals the distance traveled divided by the time of travel. For example, suppose a car travels 200 kilometers, about 124 miles in 4 hours. Its speed is 200 kilometers divided by 4 hours, which equals 50 kilometers per hour, about 31 miles per hour. With most of the motion you observe on a day-to-day basis, you will notice that an object's speed is rarely constant. Objects move at different speeds at different times. Think about how often you change speed when riding a bicycle. So in this paragraph, we're going to summarize two things. We're going to summarize the equation for average speed, which is the speed with the little line on top, which tells you that it's the average, with the distance the object traveled divided by the time of travel. And an example we have is this one to our right. So what they did to find the speed of the car, they took the distance traveled, which was 200 kilometers, and they divided it by 4 hours. That was the time it took the car to travel, 4 hours. 200 divided by 4 is 50 kilometers per 1 hour. And that is the solution to that problem. The second note in here is that they said that an object's speed is rarely constant. Constant means stays the same. Okay? They're saying that object speeds change often and a lot, and they don't remain the same. Let's move on and learn about acceleration. In science, acceleration is the rate at which an object changes speed or direction. You probably use the word accelerate to describe something as speeding up. Physicists use acceleration to describe any change in motion. If the car's speed increases or decreases, we say that the car is accelerating. If a car goes around a curve, we say that it is accelerating because it is changing its direction of travel. In this unit, you will notice that many familiar words are used with different, highly specific definitions in science. There are a couple things I want to point out. The word acceleration is the third way that we describe how we can describe the motion of an object. So we can describe the motion of an object based on its speed, based on its velocity, and based on its acceleration. A fourth way is through its frame of reference. And this is the next reading that you will be completing for lesson 2. The second note I wanted to share was their definition of acceleration. And over in the margins, it's when acceleration, and I'm going to abbreviate here, it has to involve a change. A change is going to be the the triangle is a symbol for change, a change in speed, or or a change in direction. If an object is speeding up, if it's going faster, it's accelerating. If an object is slowing down or it's going slower, it's accelerating. Or if an object is changing direction, it is accelerating. The last point I wanted to point out is I want you to take a look at this distance time graph. A distance time or a distance versus time graph graphs the distance a car travels or an object travels over the time it took to travel. I want you to notice that time is on the x-axis. Time is our independent variable, and that goes on the x-axis. Distance goes on our y-axis, okay, and that's our dependent variable. And that this is a distance time graph. So this is one way that we can measure speed. If you notice in this distance time graph, the car is actually increasing at a constant speed, okay? And that's because the line is straight. So it's increasing at a constant speed. Every 1 hour, it increases its speed by, every 1 hour, it travels 50 kilometers. So that means that its speed is constant. Well, this concludes the recorded reading for this specific reading. If you have any questions, well, let your teacher know.